Hello, everybody. This is Professor Lee. I'm going to today. We're gonna study together a very important statistical wisdom. Uh, okay, so it's anybody who knows me that I've been studying Hebrew to read Bible in its original language. So before I start this book, which is called the Seven Pillars of Statistical Wisdom. It's I think it's the author is so much similar to me because he's got his title out of Bible, Proverbs 9:1. So let's start with the Bible verse, Proverbs 9:1, 잠언 9장 1절, which says, "Wisdom has built her house; she has hewn out her seven pillars." So in Hebrew is kokmot baneta veita jajeva amudachashiva. Pardon my pronunciation. Anyway, so it's a wisdom is a person according to the scripture who can build house. It even says wisdom was with the Lord when God created the whole world. The foundations of the word that wisdom was. I don't know who this is, but the spirit of wisdom was with the Lord when the word was founded. So the pillars also suggest that kidung, so it supports a house. Okay, so for centuries, readers wondered what kind of house stands on seven pillars, as in Proverbs 9:1. So nobody builds a house that way. Recent scholarship suggests the verse was never about architecture at all. It points back to the seven sages of ancient Mesopotamia, seven wise advisors, this theory suggests, whose principles were said to be the foundation of civilization itself. Okay, so wisdom's house rests not on stone columns but on seven great ideas of the spirits, and according to Bible. So let me bring the author here, who's the statistician from the University of Chicago. So his name is Stephen Stigler, and I love Stephen. I think he was in Acts chapter 9 or 7, a martyr. And same name, well, Dr. Stigler, the world's leading historian of statistics, borrowed this image for this wonderful little book. And he claims that everything we call statistical thinking rests on exactly seven ideas. Not seven formulas, not seven software packages, not seven different AI models, but seven ideas. So here's the part I want you to hold on to the next 90 minutes. About 90 minutes, I don't know. It may go longer or shorter. Every one of those ideas, when it first appeared, sounded crazy. Each one contradicted the common sense of the smartest people in its time. But today we're going to walk through the all seven pillars. So each pillar, I want to tell you two stories. One from history, kings, brewers, astronomers, physicians, but also adding one from business. This may not from the book. And that's because a lot of my audience is business students, MBA students. So I'm going to add story from business, an example from business. So this is the word that we get jobs and we make our living in business. So let's dive into it. Okay. So this is Proverbs 9:1. Wisdom has built her house. She has set up its seven pillars. The seven spirits of wisdom, spirits of the Lord, our spirits, fear of the Lord, spirit of the Lord, spirit of power, spirit of counsel, spirit of resourcefulness, spirit of understanding, spirit of discretion, spirit of knowledge, and spirit of prudence. So let's read the whole section of Proverbs 9:1-6 so that we know where it's coming from, the context of it. So wisdom has built her house. She has hewn out her seven pillars. She had killed her beasts. She had mingled her wine. She has also furnished her table. a little bit esoteric. I believe that has meanings just encrypted. She cries upon the highest places of the city, whose is so simple, so is so simple, let him turn in hither. As for him, what that wants understanding, she says to him, come, eat of my bread, and drink of the wine which I have mingled. Forsake the foolish and live, and go in the way of understanding. So that's our prayer. We start with this book. Okay, so let's target 90 minutes, 7 ideas that were once scandalous, and now it runs your business. So number 1 is aggregation. Number 2, information. Number 3, likelihood. Number 4, intercomparison. Number 5, regression. Number 6, design. And number 7, residual. So we are kind of target about spending 10 minutes per each pillar. So, okay, so 7 resolutions. This is, I believe, 4. Okay, pillar 1. Before pillar 1, okay. 7 resolutions. Why do I keep saying revolution? Revolution. Why? 3 reasons. First, each idea was once, when it began, it was a heresy. Okay? It was heresy. It was not mainstream idea that somebody wasn't afraid to go become an outlier, to speak loud about new ideas that was revolting to a lot of people, incumbent people. So when the economist Jevons proposed averaging price change of different goods into one index number in 1860, critics laughed at him. How can you average pig iron with pepper? Okay, those are different things. So today we call it absurd average as the Consumer Price Index, CPI, which is a foundation of central banks move trillions of dollars based on it, raise the interest rates, go up and down based on CPI. You can hear it in Wall Street and Bloomberg all the time. When it first started by a guy, Javons, everybody thought he was crazy. But history is made by a lot of crazy people who's not afraid of the peers, stupid people who don't understand him at the same age, okay, which may be the same. So when you don't fit into the average people, that's fine. I say it's fine. When Fisher proposed deciding experiments by literally rolling dice, randomization, okay, senior scientists thought that you're crazy. Have you abandoned scientific control? Why are you doing this? But today, a drug cannot be approved without randomized experiments. See? So that's the history. Second, each idea still gets attacked in almost the same words. So you're treating people as mere statistics. With big data, we don't need sampling. P-values exert real science. You hear about all these, criticisms in your career all the way. Probably from someone senior to you, probably from someone junior to you, probably from your colleagues and students all the time. But sometimes the complaint is fair about a specific misuse, but notice the attack is usually aimed at the tool itself. And the real problem is hands holding it. Which brings me to the third point. Back in 1927, a statistician called Ed Wilson gave a warning that I want to put over the door of this course. A person untrained in statistics, who uses statistics anyway, is holding one of the most dangerous insurances of all science. So statistics are a power tool. So that's our safety training. A lot of communist government use and misuse statistics to mislead their people and put them under oppression. So it is, the manipulate statistic is one of the most how to say, strongest weapon that we need to destroy. Okay, so start from pillar one, aggregation. Pillar one, the oldest pillar. As Stigler, the author himself, Stephen Stigler, insists the most radical pillar, which is strange because pillar one is just average. You learned it elementary school, so how can the arithmetic mean radical? Okay, so think carefully about what you do when you take an average. You take 10 measurements, each one made by a specific person at a specific time under specific conditions, all different. And you deliberately destroy the specificity of each case, person, and condition. Who measured it? Gone. What order? Gone. Was the third measurement made by your most careful analyst and seventh by an intern? Gone. The average doesn't care. Each observation loses its identity in aggregation. So for most of human history, that felt like vandalism. Imagine you're an astronomer in 1750. You have 5 measurements of a star's position. You know, the third one was made on a perfectly clear night by your best instrument. The natural instinct, the intelligent instinct, is to keep the best one and throw away the rest. Averaging your best measurement with your worst ones feel like polluting good data with bad. In 1874, when nations around the world timed the transit of Venus across the sun to measure the solar system, people seriously asked, can numbers from different cities, different telescopes, different observers really be thrown into one big average? Okay, the statistical revolution was the discovery that the answer is yes, and more than yes. A summary can contain knowledge than any of its parts. Individual errors with each with its private history, private story, partly cancel each other. By burning the details, you see the pattern. So less detail, then you come to the more concentric truth. That is deeply counterintuitive, and people resisted it for centuries. The writer Louis Borges, the Nobel literary award winner, 100년 동안의 고독? He captured the deep logic in a short story. It's another story of not 100 years, but Funes the Memorious. Funes is a guy who, after an accident, remembers everything. Every leaf on every tree, every cloud, every minute of every day forever. And Borges' devastating point, precisely because Funes forgets nothing, he cannot think. To think, Borges writes, is to forget details, to generalize, to abstract. So Funes drowns it in particulars, therefore he cannot generalize or come to an abstract ideal truth. So remember this phrase, Funes is a big data without statistics. A company data lake that stores every click, every scroll, every second and produces no understanding is a Funes with a server, a big server bill. Now, the dashboard versus the loudest anecdote. Now, the business story. Your product has 2,000 reviews on the App Store, distributed like this chart. So mostly 4s and 5s, decent numbers of true 3s, and about 120 angry 1-star reviews. So average 4.1. So here's what actually happens in companies. So one of those 1-star reviews is Vivid. The app deleted my wedding photos. No, it gets screenshot. It reaches the CEO's phone at 11 p.m. The next morning, the roadmap changes, not because of 2000, because of the 1. Okay, so psychologists have a name for the general pattern: vivid, concrete stories, vivid, concrete episodes beat pale, abstract statistics in human decision making. And essentially, every time, unless someone in the room deliberately push back. So our pillar 1 is that pushback. The mean of 2,000 voices carry more knowledge than any single voice, including the loudest, the saddest, the most senior one, okay? Or the baby cry. There is even a nickname for decisions driven by the loudest voice in the room. That's called the hippo. Hippo, HIPPO, the highest paid person's opinion. Now, aggregation is the antidote to the hippo. And notice how far this pillar reaches. Net Promoter Score is an aggregation. Customer satisfaction indices, aggregation. Average order value, click-through rates, aggregations. Even regression by least squares, which sounds fancy, is at the bottom. Clever weighted average, an average that adjusts for other characteristics for each data point. So entire dashboard culture of modern business stands on pillar 1, aggregation. One important clarification, because I do not want you to leave this video as data bullies. The complaint that you're training people as statistics deserves a serious answer. Answer is that treating people as statistics is not a sin. The sin is refusing to see the pattern, letting one vivid case or your own favorite case overrule 2,000 quiet ones. So the individual stories are not false. They simply have to step into the background if the general truth is to step forward. Okay. Next pillar, information. Pillar 2, the measurement of information. If pillar 1 says observations creates value, pillar 2 asks the follow-up. Every CFO asks, what is the marginal value of one more observation? The answer turns out to be one of the most useful and the most ignored facts in all of applied statistics. So, the ancient Greeks already sensed the problem through a puzzle called the paradox of the heap, H-E-A-P, heap. 1 grain of sand is not a heap. Adding 1 grain to something that is not a heap, sure, you cannot make it a heap. Yet heaps exist. 5 centuries later, the physician Galen turned the paradox on medicine. If one cured patient doesn't prove a treatment works, and adding 1 more case never flips the balance, how does evidence ever accumulate? Everyone agreed more evidence was better. Nobody could say how much better. For roughly 2,000 years, nobody could. So now let me show you what the ignorance cost through my favorite story in the whole book, the trial of PYX. Since the 1200s, 800 years, it still happens today. The London Mint has faced an audit. 화폐국이죠, mint. Each day of production, sample coins go into a wooden box called PYX. Periodically, the box is opened before judges, and the coins are weighed against the royal standard. It's arguably the oldest continuous quality control process in the world. Beautiful, right? Except for one box. The contract allowed each single coin a small tolerance. Call it capital R. R, because everyone understood coins vary a little. For a batch of 100 coins, the judge allowed a tolerance of 100 times R. Sounds perfectly fair, and it is completely wrong. Here's why. When errors are independent, this coin is a milligram heavy, that coin is milligram light, they partly cancel it in the total. So the variability of a sum does not grow like n. It grows like the square root of n. So the fair tolerance of 100 coins is not 100 R. It is about the square root of 100 times R. Just 10 R. The official tolerance was 10 times too generous. Okay? Which means a clever master of the mint could aim slightly low, make every coin just a little light, keep the extra gold, and pass the trial forever. The statistical test was so loose that it could not catch systematic shaving. And who ran the mint from 1696, 1727? Sir Isaac Newton, the greatest mathematician alive, in charge of a rigged test for 30 years. He died wealthy. Historians assure that it was his investments. We make no accusations. We simply note that Newton, of all people, could have done the math. So formal discovery came in the 1720s and 1730s. Abraham de Moivre, working out the mathematics of coin flips, found the square root of n, sitting at the heart of binomial distribution. The seed of what became the normal curve, and the rule every one of you will now memorize: precision grows with the square root of sample size. So why your research budget obeys this square root of n law? Look at the chart from the slide, previous slide again, because it's a chart about money. Sample of 100, margin of error around 10%, sample of 400 about 5%. To get from 5% to 2.5%, you don't add 400 more respondents. You just need 1,600 in total. So to cut the error in half, you must quadruple the data every time. This single fact explains an industry why do virtually all national polls use samples around 1,000, because 1,000 guys you roughly plus minus 3%. And the next meaningful improvement costs 4 times as much as of a gain. For a gain, nobody's headline will notice. So why does your market research quote 400 respondents as a standard package? Same law. The root and rule is written onto every price list in research industry, even when nobody in the meeting can derive it. Now, the big data correction, the part of the pillar your generation specially needs. 10 million loyalty card records, the margin of statistical error is essentially 0. About 300ths of a percent. So we are done, right? No sampling theory needed. Be careful. The square root of n rule shrinks one kind of error only: random sampling noise. It does nothing for bias. So if your 10 million records come only from customers who join the loyalty group, you may have an enormously precise measurement of the wrong population. So in 1936, American Magazine polled over 2 million people and confidently predicted the wrong winner of the presidential election. 2 million people and the wrong prediction, because the sample was tilted toward wealthier voters. 2 million. So size cannot fix tilt. 10 times more biased data, simply 10 times more confidence in the wrong answer. So the trial of PYX also lives on. And by the way, everywhere quality is monitored by samples, Six Sigma control charts, Core Center QA, Amazon Seller Metric, Food Safety Batch Testing, all of them are PYX with the square root of n bugged fixed. So one sentence takeaway: before buying more data, ask what next unit of data actually buys you. And remember that no quantity of data buys you out of bias. Okay, move on to number 3. Pillar 3, likelihood. Likelihood, in plain language, how to put a probability measuring stick against your evidence. This is the pillar behind every p-value, every significance star in a regression table, ever statistically significant in a headline. And it was invented essentially on one page in 1710 by a physician comedian. So, Dr. Arbuthnot, strange discovery. John Arbuthnot was Queen Anne's personal doctor, famous in London as a satirical writer. He is also liked mathematics. One day he examined the city's christening records, baptism records, effectively birth records, and noticed something odd. Year after year, slightly more boys than girls were christened. Not occasionally, every single year, 82 years in a row. So here's the beautiful move, the move that founded the whole branch of reasoning. Arbuthnot said, suppose sex at birth really were like tossing a fair coin, boys and girls 50-50. Then in a given year, more boys would have probability 1/2. For that to happen 82 years running, 1/2 raised to the power of 82, 2분의 1에 82승. Write it out in roughly one chance in 5,000 billion, a number with 25 digits, effectively impossible. Okay, so the conclusion. The fair coin assumption must be wrong. Something systematic pushes male births slightly higher. So Arbuthnot, a man of his time, concluded it was a divine providence. And his paper was literally titled Argument for Divine Providence. So even offered a theory. Boys face more danger, so providence ships a few extra. Modern biology tells a different causal story, but notice what survives the method. Assume pure chance. Compute how surprising your data would be under pure chance. If the answer is astronomically surprising, reject pure chance. That 3-step dance is the significance test. Every p-value you ever compute is Arbuthnot argument wearing modern clothes. So this is a second lesson in his paper. Arbuthnot also calculates something counterintuitive. As the number of births grow, an exact 50-50 balance becomes rarer and rarer. With 10,000 births, the chance of a perfect tie is under 1%. So chance produces imbalance all the time. Small imbalances mean nothing, but entire art is know how much imbalance chance alone can produce. How much imbalance chance produces versus how much imbalance that is caused by systematic force. So that's exactly the probability measuring stick measures. The new checkout page, lifted conversion. Okay, so fast forward 300 years to a meeting you personally attend with 5 years of graduating your business and MBA schools. Your team redesigned the checkout page. The A/B test results are in. Old page, 5% conversion on 10,000 visitors. New page, 5.6% on 10,000 visitors. A 12% relative lift. So design team has already ordered celebration chicken. Before we open the chicken, hands up. Who ships the new page? Now, let us be Arbuthnot. Assume the two pages are truly identical and the difference is pure luck, in which visitors happen to land where? How often would the random traffic alone produce a gap of 0.6 percentage point or more? Run the numbers, the answer is roughly 1 time in 16, a p-value about 0.06. In other words, if you ran this experiment on two identical pages 16 times, you would expect one result at least this impressive by luck alone. So, is the new page better? Maybe, probably, even, but probably is not what the slide deck claimed. The honest summary is suggestive, not settled. One more week of traffic would likely settle it. And the 1 week difference is exactly the difference between a data driven company, a company that equates its hunches with data. So, 2 pieces of discipline come with this pillar. First, set your threshold before you look at the data. If you decide what counts as convincing after seeing the result, you always convince yourself. Second, and this is the sin every experimentation platform now policies, is do not peek at the test every day and stop the moment it looks significant. If you keep checking until you see a win, you will find one. The same way you will eventually flip 5 heads in a row if you keep flipping. So analysts call it optional stopping. I'll call it lying to yourself slowly. So last nuance, and it matters for your future salary negotiation. Statistical significance answers, is it rare? It never answers, is it big enough to matter? So with huge samples, a lift of 0.1 percentage points can be highly significant and worth absolutely nothing. So significance is a gate, but it's not a goal. Business judgment about effect size walk through the gate afterward. Okay, number 3 down, 1 to 3 down now. Number 4, inner comparison, letting data judge itself. Now, pillar 4 has the least friendly name, inner comparison. And the friendliest origin story in the history of science. It answers this question: can a data set judge itself? Can the yardstick for surprising come from inside the very data you're testing? Okay, student of Guinness, Dublin in 1908. Around 1900s. The Guinness brewery, 맥주, decides to get scientific about beer. So they hire young Oxford graduate with training in chemistry and mathematics. And one of them is William Seeley Gossett. His job is deeply practical. Which barley variety should Guinness grow? Which hops should they buy? Does this batch meet the standards? So he immediately hits over. All the statistical theory of his era was built by astronomers with hundreds of observations, where you could treat your estimate of variability as essential exact. Gossett had 4 fields, 6 batches, 8 measurements. At that size, the classical methods quietly break. They pretended you know the variability precisely when you have only a rough guess of it, so they are systematically overconfident. Gossett even wrote, a bit desperately, that none of the textbooks would tell him that odds were sufficient to establish a conclusion. Perhaps they should consult a mathematical physicist. So Guinness did something wonderful. They gave their brewer a sabbatical to study statistics in Carl Pearson's lab in London. So in 1908, Gossett published the solution, a way to test an effect using the variability inside the small sample itself, with an honest mathematical correction for the fact that your yardstick itself is uncertain. The smaller the sample, the more humility the formula forces on you. Now, the best detail. Guinness had a strict policy. Employees could not publish under their own names, trade secrets, you understand. So most widely used statistical tests in the history of science published under the pseudonym student. When Ronald Fisher later reworked the mathematics into today's form, the name stuck. So student's t-test. Every t-test in every regression table you ever read is named after a beer company's and confidential policy. So understand what was philosophically radical here. Critics ask, how can the uncertainty about the word be measured from inside one small data set? It sounds like lifting yourself by your own bootstraps. Hold that word because 70 years later, when computers arrived, statisticians built a technique that resamples your own data thousands of times to measure its own uncertainty, and they named it, with a wink, a bootstrap. The bootstrap, Pillar 4, reborn in silicon computer, even with weaker consumptions. So small samples, rare decisions. Why should a marketing student care? Because you live in a ghost's world, not the astronomer's world. Look at the 3 cards. Product and sensory testing. 8 tasters try to reformulate this snack. 5 store pilot the new shelf layout. You never get 10,000 observations before launch decision. The T family of methods exists precisely so that small samples can still support honest probability statements. So B2B and niche markets. Suppose your customers are 30 hospital purchasing directors or 12 shipyards in the entire country. Collect more data is not the advice. That's a fantasy. So inner comparison is what makes small N research respectable rather than apologetic. In modern analytics, when your data is weird, skewed revenue distribution, strange customer matrix, no textbook formula applies to this skewed distribution or customer metrics strange, then the bootstrap lets the data build its own confidence interval. Resample, recompute 10,000 times, read off the spread, philosophy of 1908, horsepower of 2026. One warning labor, though, straight from the Stigler himself, the power to generate a valid test from internal variation alone, without any external scientific standard, can be abused. A perfectly valid test of meaningless question is still meaningless. So the tool does not supply the wisdom. It's your job to supply wisdom. And Spirit of wisdom help you. May the Spirit of wisdom help you. Spirit of truth will guide you. All right. So a lot of what we do have small sample size, something to keep in mind. Pillar 5 is regression. If I could force every future manager to master exactly one pillar, this is the one. It costs companies more money, reads more performance reviews, sells more useless consulting than any other statistical mistake. It hides inside a puzzle about tall parents. So start and go back in 1885. Francis Galton, Charles Darwin's cousin, was measuring families. He wanted mathematics for Darwin's theory of evolution and was troubled by a contradiction. Selection seems to require ever-increasing diversity, yet species look stable across generations. In the heights data, he found something strange. The children of very tall parents were tall, but on average less tall than their parents. The children of very short parents were short, but less short than average. So everyone seemed to drift toward the middle. He first called it reversion toward mediocrity. So your first instinct is to build a theory about biology. Maybe genes get diluted. Maybe nature pulls everyone toward average. Here's why every such story is wrong. Galton found the same pattern running backwards in time. Take every tall children, their parents are on average shorter than they are. Wait, children drift toward the average of their parents and parents drift toward the average of their children? Nothing can causally flow from that direction in time. Whatever that is, it's not a force. Nobody is being pulled anywhere. Here's a clean, modern way to see it. Any extreme result is a mixture. Extreme result equals true underlying level plus unusual luck. So to be the very tallest group, you generally need both tall genes and a favorable role of all random factors of growth. Your children inherit a share of the genes, but luck resets. So they are tall, yet a bit less extreme. Run the logic in any direction or any pair of imperfectly correlated measures, you get the universal rule. Select something because it's extremely on one measure and it will on average be less extreme on the other. Always, automatically, no cause required. So 2 big footnotes before the fun parts. First, this is why your regression course is called regression. The name of entire technique comes from this one phenomenon. Second, Stigler argues this discovery quiet overturned 3,000 years of proportional Euclidean style thinking and gave science the machinery of conditional distributions. The mathematics underneath multivariate analysis, Bayesian inference, modern causal inference, one puzzle about tall families, and the whole toolbox falls out. Also note Galton's deeper lesson. The same data gives radically different answers depending on which direction you ask the question. Predicting child from parent and parent from child are difficult and different questions with different answers. Asking a question from a different perspective can change the answer. Remember that when you write survey questions. Now, the manager's favorite illusion and 4 sightings. Let us go hunting. Regression to the mean wears 4 favorite business costumes. Costume 1, salesperson of the year. Your number 1 rep of this year will most likely rank lower next year. Not because success made her lazy or him lazy, because this year's number 1 needed great skill and great year of luck. The big client that landed her on her lap or the competitor stumbled in her region, next year's skill remains but luck re-roars. Companies that don't even understand this conclude their stars got complacent and design punishing bonus systems to fight the phenomenon of pure arithmetic. Custom number 2, the turnaround campaign. Sales crash in the 3rd quarter. Panic. You hire an agency, launch an expensive campaign, and the 4th quarter sales recover. The agency puts your logo in its case study deck, but ask yourself, what do crushed sales tend to do next quarter, campaign or not campaign? They tend to rebound because a crush too is usually part real trend and part bad luck, and bad luck expires. So without a control group, you cannot distinguish the campaign from the calendar. So a great deal of marketing ROI, return on investment in this world, is regression to the mean, wearing a marketing costume and sending an invoice. Costume number 3, my favorite from the psychologist Daniel Kahneman. And he was teaching flight instructors, and one flight instructor objected to the research on praise. In my experience, when I praise a cadet for an excellent maneuver, he flies worse next time. When I scream at cadet after a terrible maneuver, he improves. So criticism works better, praises backfire. Do you see it? An excellent maneuver is skill plus good luck. The next attempt is closer to average. So it looks like praise hurts. A terrible maneuver is skill plus bad luck. The next attempt improves, so it looks like screaming worked. Instructor was not observing psychology, he was observing arithmetic and drawing a life philosophy from it. And Kahneman called this the most important statistical insight he ever taught. Because he reward after good performance and punish after bad, regression guarantees that punishment appears to work and kindness appears to fail. Think about that. The one illusion has done to management culture, to parenting, to education for centuries. Costume 4, Selection everywhere. So last year's mutual fund, hottest mutual fund, the candidate who gave one dazzling interview, the restaurant that was perfect for the first time, the product that went viral in March, select on extreme and sequel disappoints on schedule. So it's not a mystery to investigate. It's just text on selecting extremes. So rule of thumb, to tattoo somewhere, not to the tattoo, but really inscribe on your mind. Whenever you selected something because it was extreme, expect the next measurement to be less extreme. And do not invent a story to explain it. Do not explain it. It's just a simple regression. The story inventing is the trap. Humans are story machines. And regression to the mean is the noise our machines most love to narrate. Okay, so pillar 5 down. Now 6, design. The planning of how data comes into the world. Stigler means it broadly. Experiments, yes. Also surveys, pilots, quality monitoring, even the discipline of asking for purely observational data. If I could have designed the idea study, what would it look like and how far is my data from that idea? Okay, so the oldest trier on record is Bible, Book of Daniel, chapter 1. Daniel and his 3 friends are captives of Nebuchadnezzar's court in Babylon, ordered to eat the king's rich food and wine. But Daniel wants to keep a diet of vegetables and water. And the steward is terrified. This young man look weak. It is his head. Punishment. So Daniel proposes, in effect, a protocol. Test your servants for 10 days. Give us vegetable and water and eat king's food. Let others eat the king's food. So then compare our appearances and decide based on what you see. So look at the structure with modern eyes. A treatment group, a comparison group, a fixed duration, a pre-declared endpoint. 26th century ago, Daniel's group, the text reports looked healthier and the diet was approved. So I'll resist the temptation to spend 20 minutes here, but note the comparative thinking about evidence is genuinely ancient. 1,000 years ago, the great Persian physician Avicenna, Ibn Sina, went further. His Canon of Medicine, the standard medical text for 6 centuries, lists 7 rules for testing drugs. Test pure substances on uncomplicated cases. Check consistency and timing. Watch dose response. Replicate. It reads like a modern checklist, a millennium early. Humanly slowly assembled almost all the ingredients of good experimentation. Almost all. One ingredient was missing, and it was the strangest one. In the 1920s, at an agricultural research station called Lothamsted, Ronald Fisher proposed assigning treatments to field plots by delivered chance randomization. So, to centuries of experimental philosophy, this sounded insane. Science means controlling conditions, and Fisher wanted to roll dice. But Fisher saw what no one had seen. If chance itself assigns the treatments, then chance is fully under your mathematical control, and the randomization alone justifies the inference. You no longer need to assume the soil is uniform or the subjects identical, errors normally distributed. The dice carry the proof. On top of that, Fisher showed you should not test one factor at a time. His factorial designs vary several factors together, so you can measure not just each factor's effect, but their interactions from the same experiment. So experimental science needed a generation to accept it. Then it conquered everything. Agriculture, medicine, eventually your industry, randomization. Every A/B platform is Fisher's farm in disguise. So, because what is an A/B test? You randomly split incoming visitors between page A and page B. Why randomly? Because random assignment makes the two groups equal in expectation and everything. Device income, mood, weather, time of day, crucially on every factor you never thought of. That last phrase is the miracle. Matching groups or known group factors is bookkeeping. Being protected against unknown factors is magic. And randomization is the only spell that casts it. So it is why an A/B test supports the word causes, while a correlation study only supports the word associate. So Netflix, Amazon, Coupang, Toss, the big platforms run thousands of randomized experiments simultaneously every day. Fisher's muddy field at web scale. Fisher's factory idea also lives in marketing under a name you will never meet, conjoint analysis. Do not test price alone, the package alone, the message alone. Vary them all together cleverly and you learn the interactions. Perhaps the discount only works when paired with the premium package. One design study triple the insight. And you must also learn to smell design failure, because bad design cannot be rescued by clever analysis afterwards. 3 sniffs. The Pepsi Challenge famously beat Coca-Cola in blind taste tests using single sips. Sweeter drinks win sips, but a whole can is different experiment. And design determined the answer before first taster arrived. Coupon campaigns proving lift among customers choose to redeem the coupon. Self-selection, not causation. Satisfaction surveys sent only to current customers. The unhappy ones already left. So you're serving the survivors. So takeaway, it may be the most practical sentence of the day. 1 hour of design is worth a month of statistical repair. Plan the analysis before you collect a single data point in your term project proposals. The design section is where your grade and later your budget is won or lost. Finally, the 7. Residual. Pillar 7 is the residual. This name sounds like leftovers. Honestly, it is about leftovers, but leftovers turns out to be where the discovery lives. In 1831, the astronomer John Herschel wrote a famous book on how science actually advances. His answer: rare phenomena are tangled mixtures of many causes, so take the causes you already understand, calculate the effects, and subtract them. Whatever remains, he called it the residual phenomenon. It is the frontier. Study the leftover and you'll study exactly the part of the world you don't yet understand. So the most spectacular success of this method is Neptune. Astronomers computed Uranus's orbit from every known gravitational pull, the Sun, the Jupiter, the Saturn orbit, and Uranus refused to follow the prediction. A small, stubborn leftover wobble. 2 mathematicians treated the residue as a signal, calculated where an unknown planet would have to be to produce it, and told the observatories where to point. Neptune was sitting there within a degree of the prediction, a planet discovered inside the error term. So fairness requires a failure story too. Herschel's own showcase example was the luminiferous ether, a substance invented to explain certain leftovers in physics, in which, after 70 years of searching, turned out not to exist. So residual reasoning can chase ghosts. 유령, ghosts. So this is precisely why statistics matter here. It took Herschel's art and gave it discipline, fit a model, examine what it fails to explain. If you see structure in the leftover, propose a richer model, and then formally test whether the additional terms earns its keep or whether you're just fitting noise, every significance test on a regression coefficient, every mother comparison you run in the scores is one turn of the loop. The loop stops when the residual finally looks like pure patternless, no pattern noise, meaning your model has captured everything the data can currently teach. So marketing mix model is a Herschel with a P&L, profit and loss statement. Now the business version, and it's a big one. The pillar is the entire logical marketing mix modeling. Look at the stacked chart. Monthly sales decomposed a navy line, baseline, and you would sell anyway. Teal seasonality layer, the calendar braiding, a gold promotion layer, your campaigns, and an amber silver. On top is residual. What none of it explains. So what the month is with me, and stop at March. Baseline, normal, no promotion. Season, nothing special. Yet March sits 7 units high. And the mother shrugs. The amber silver is not annoying noise to delete. It's a Neptune. So something happened in March that your mother doesn't know about. A competitor stock out, a viral post you never tracked, an influencer never paid. The residual is a detective's clue telling you where to dig and possibly where next year's growth is hiding. Second use, the corporate Occam's razor. The team wants to add influencer spent to the model. Fine, add it, and then ask the Pillar 7 question. Does the model explaining meaningfully more with it than without it? Occam's razor. Beyond what log would grant such extra variable? If yes, the coefficient stays and influencer marketing earns budget. If no, it doesn't. It dies. So nested model comparison is how grown-up organizations decide which stories about their own success are actually true. Third, anomaly detection. Frauds alert, churn spikes, demand sensing. The good systems never watch raw numbers, they watch residuals. So raw sales falling in February might be perfectly fine. February is short and slow. The model explains a large residual is never fine. Lower than expected, given everything we know, is a completely different sentence from lower than last month. Pillar 7 is what makes better sentence computable. So one-line version, baseline sales equals baseline plus seasonality plus marketing plus epsilon. That epsilon error. Your career in large part is ongoing integration of that epsilon or E error. So this is the synthesis. One house and 7 pillars. Let us put the house back together. Read them as 7 one-sentence creed. Aggregation, compressed data on purpose. A good summary knows then its parts. Information, knowledge grows like square root of n. Budget your data accordingly. Likelihood, measure surprise with probability before you build a pattern. Intercomparison, even small data can judge itself using its internal variation. Regression, extremes revert. Never write a story for an arithmetic already explains. Design, decide how to collect before you collect. Randomize whenever you can. Residual, explain what you can, then hunt inside what is left. Now take out your score sheet from the beginning. Which pillar did you give the lowest score? The one your intuition registers the most. Look at it again. Has the number moved? Which do you think was the most important? Now you don't think so? Okay. Stigler point is that these ideas are not mathematics nor computer science. They are a distinctive way of thinking, human thinking. The pillars that feel wrong to you are precisely the ones where your untrained intuition would have cost you money. Okay? Argue with the pillars. So now these are some exercise question. Question one, a CMO says we have 40 million loyalty card records. With data this big, we no longer need sampling theory or significance tests. Which pillar answer her and harder? Where does she actually have a point? Question two, your agency reports every score they received a new display, so sales rise from the last quarter. Using design and regression, write 2 questions you would ask before paying the invoice. Question 3, Netflix says fullness level detail on every viewer. Pick 2 pillars and name a concrete place Netflix still needs each. So, let us close where we began with Wisdom's House. This is the sentence I want you to think about when leaving the room. Wisdom is not the data. Wisdom is what you dare to do to the data. You dare to average it, knowing that you may destroy it in detail. You dare to bound it with the square root of n. You dare to test it against pure chance. You dare to let it judge itself. You dare to expect a rebound instead of narrating it. You dare to design before you collect. And you dare to keep interrogating the leftovers, because that's where the next discovery is hiding. Okay, so I also am providing the Stigler's book for text. So I hope this is an interesting stimulation for you about why we need statistics to make a correct and sound judgment for your business decisions. Thank you very much.